Welcome to This Explainer, where we are going to completely level up how you tackle the Cambridge Computer Science exams. Think of yourself not just as a student, but as a game designer, and today we are breaking down the ultimate boss fight, exam strategy. Whether you're navigating the 0417, 0478, 0983, 0984, 2010, or stepping into the heavy-hitting ASNA Level 9618 syllabus, the rules of the game are exactly the same. Today, we are systematically decoding how to construct answers that absolutely command top marks, using first normal form, or 1NF, as our primary battleground. If you've been reviewing your notes, staring at database tables, and wondering why your hard work isn't translating into an A-star, you are in exactly the right place. Every single paragraph you write should unlock new insights and, more importantly, new marks. We're going to strip away the confusion, look at actual past paper scenarios like the infamous Code 9713, rely strictly on raw examiner data, and build a systematic approach to completely mastering your exams.
Here is the roadmap for our strategy session today. Think of these as the 5 levels we need to clear. Level 1 is the 1NF exam challenge, where we identify exactly why students lose marks. Level 2 is core theoretical foundations, where we look at what the examiners are actually begging you to write. Level 3 is the procedural framework, introducing the exact system to secure every single method mark. Level 4 dives into top examiner warnings, those hidden traps you have to avoid. And finally, Level 5 is evaluation and strategy, where we put it all together to maximize your final score.
Let's jump right into Level 1, the NF exam challenge, and specifically why students struggle so much. We're starting our journey by looking directly at the analytical battlefield. Picture a real Cambridge computer science past paper question. The clock is ticking. The pressure is on. I want to introduce you to 2 very typical students we see all the time. First, we have Alex. Now, Alex has memorized the entire textbook. Alex overloads every answer with raw, unfiltered computer science facts. If a question asks about 1NF, Alex writes a novel about databases, but includes absolutely zero context or analysis. Then we have Sam. Sam is always rushing. Sam sees a question, panics about the time, completely misses the specific command word requirements, and writes a 1-sentence answer that completely misses the point. When we put their answers side by side, it is just a sea of red pen marks from the examiner. They both studied hard, but they both failed the strategy game.
And it's not just me saying this. What is genuinely fascinating here is an insight straight from the examiners themselves. They explicitly state that first normal form is one of the most misunderstood areas in computer science. Why? Because candidates face an immense challenge trying to distinguish between very similar concepts, and they approach the questions exactly like Alex or Sam. You might know what a database is, and you might even vaguely know what atomic data means, but if you don't structure an answer to meet the exact analytical criteria the examiner is holding in their hand, that knowledge is useless. This is where the confusion sets in, and this is exactly where we start clawing back those lost marks.
That brings us to Level 2, core theoretical foundations. It's time to transition from knowing why students fail to understanding exactly what examiners actually want to see on your paper. We are going to decode the specific assessment objectives for computer science and reveal how top-tier students structure their thoughts.
So, here is the golden rule, the crucial point of this entire explainer mastering 1NF, or any complex computer science topic, isn't just about memorizing facts. It's about proving you can apply logical, evidence-based reasoning to entirely new, completely unfamiliar contexts. It is a conceptual framework. Before we continue and reveal exactly how to apply this framework to your next paper, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. When examiners throw a bizarre, highly specific database structure at you in the exam, say a relational schema for a futuristic robot factory, your systematic analysis skills need to kick in automatically. You have to demonstrate connected understanding, not just isolated trivia.
This brilliantly illustrates the exact standard you are being judged against. Examiners are relentlessly prioritizing deep, structured reasoning over a wide but completely shallow pool of knowledge. Superficial breadth is Alex's problem. Knowing a tiny bit about everything, but not truly understanding how things connect. To achieve analytical depth, you need a system. This is where the PEEL framework comes in as an absolute game changer. PEEL stands for point, evidence, explanation, and link. You make your specific point, provide evidence from the given scenario, provide the technical explanation of why it matters, and link it back to the specific question asked. If you aren't using the PEEL framework, you are leaving marks on the table.
Now let's move to Level 3, the procedural framework.
With the PL theory locked into your mind, let's see how this builds into an exact procedural framework to secure those all-important method marks. We are moving from theory to execution. This standardized 5-step sequence is literally your algorithmic lifeline during a high-pressure exam. It ensures you don't miss a single step in your problem-solving decomposition. Step 1, you identify the key elements of the scenario. Step 2, apply the relevant principles, like eliminating repeating groups for 1NF. Step 3, execute your analysis with clear, readable working. Step 4, verify those results. And Step 5, presented perfectly. Let's do a quick 30-second mental challenge right now. Imagine an answer that just says, the table is in 1NF because the data is atomic. Is that a PL paragraph? No way. It has a point, but absolutely no evidence, no explanation, and no link. The 5 steps ensure you build out the complete PL structure every single time.
This systematic processing mindset goes way beyond just answering database questions. It translates directly into your practical programming skills. The syllabus demands that this structured reasoning applies to how you design algorithms, implement your solutions efficiently in code, test them thoroughly, and evaluate their overall performance. The logic of normalizing a database to 1NF and the logic of writing clean, efficient code are deeply intertwined. They both require you to use our success blueprint. Break the big problem down, systematically solve the pieces, and prove your work.
We've reached level 4, top examiner warnings. This is the transformation stage, where we take those red pen marks from Alex and Sam and turn them into green check marks. These are the insider secrets and top warnings straight from the grading room.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at aceexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, take a very close look at these 3 traps. The first mistake is vague answers. Examiners absolutely hate when you write around the topic without giving specific, hard technical details. The second mistake is massive. The sheer number of candidates who lose marks because they forget to test their data against boundary conditions or edge cases is staggering. Always test the extreme limits of your proposed solution. But the third trap, that is the most fatal mistake of all.
The ultimate exam trap is providing a generic, memorized response. Remember Alex? Alex memorized the textbook definition of 1NF and just pasted it onto the exam paper. 0 marks. The syllabus strictly demands an answer deeply rooted in the specific context of the question. If the exam presents a scenario about a veterinary clinic's booking system, your answer must explicitly name the pets, the owners, the appointment times, and the specific data anomalies present in that exact table. This is how you transform an answer from a generic failure into a highly specific green checkmark success. You have to write live, dynamic answers, not recited poetry.
Let's enter our final level, level 5, evaluation and strategy. This is our interactive workshop segment where we lock down how to maximize your score by evaluating your own work like an examiner would. Get ready because we're going to put you on the clock.
For Challenge 1, our data scan challenge, I want you to adopt this specific problem-solving model. Deconstruct, solve, evaluate. Imagine a complex data table in front of you. You have 60 seconds. First, deconstruct. Identify the given information and break it into logical steps. Second, solve systematically using your PEL framework. But step 4 is where the absolute magic happens. You must continuously check the reasonableness of your answers. If your database solution requires a user to enter their name 40 times, is that reasonable? No. Finally, make completely justified recommendations based on your findings.
Moving to Challenge 2, the Find the Flaw segment. I want you to ask yourself this critical question. How do we effectively evaluate algorithm quality or database quality in 1NF? When reviewing a flawed sample paragraph, you have to look at it through the examiner's eyes. The metric they use to grade you is entirely based on how well you justify the quality and efficiency of your solution. If you just say an algorithm is good or fast, you are Sam, rushing and missing the command word. You have to be precise.
For Challenge 3, our speed writing challenge, you need to write one perfect PEL paragraph, incorporating these exact evaluation requirements. The secret to evaluating algorithm quality lies in addressing these 4 distinct criteria. You must ensure you account for time complexity, specifically how fast the algorithm runs as data scales up. You must account for space complexity, how much memory the system is eating up. You absolutely have to consider those edge cases we talked about earlier. And finally, you have to clearly explain how all of these elements interact to affect the overall system performance. A perfect paragraph touches on these points with specific evidence.
As we pull all this together into our cheat sheet recap, remember the 3 rules that guarantee top marks. First, command word decoding. Know exactly what the question is asking. Second, strict application of the Peel framework. And third, utilizing a time management matrix so you don't end up rushing like Sam. And if the command word asks for a comparative analysis, your data interpretation skills are absolutely critical. You cannot just list features. You must explicitly state both the similarities and the differences. You need to use comparative connectives, like whereas, however, or in contrast. And most importantly, every single claim must be backed by hard evidence from the scenario to draw your conclusions. So, here's my provocative question to you. If you applied this 5-step procedural methodology to your next past paper right now, would your answers actually survive the edge case test? Would they hold up to the Peel standard? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. Take these frameworks, apply them systematically, and watch your marks transform. Keep analyzing, and I'll see you in the next one.